For all of these examples, the process is still the exact same. Take my coefficient of x squared, multiply it by my constant, and I'm going to get negative 18. I need two factors of negative 18 that add up to positive 17, which is going to be negative 1 and positive 18. Split up the middle term. Doesn't matter which order I do this in, so I could say that it's 6x squared, and I can either say minus x plus 18x, or I could say plus 18x minus x. It's still going to factor down to the same two factors. So minus x plus 18x minus 3. Factor by grouping, and I get x and 6x minus 1, and positive 3 and 6x minus 1. Do a quick check that these are the same, which they are, and I get 6x minus 1 and x plus 3. Example B, take the 3 times negative 8, looking for two factors of negative 24 that add up to negative 2. And they're going to be negative 6 and positive 4. Split my middle term, and I have 3n squared minus 6n plus 4n minus 8. Factor by grouping, and I can pull out a 3n from here and be left with n minus 2. And I can divide both these by 4 and be left with an n minus 2. What's in the brackets matches, so it's going to be n minus 2 and 3n plus 4. Example C, 12 and 1 have a product of 12. Two factors of 12 that add up to negative 8. Well, if it's a positive product but a negative sum, both numbers have to be negative. Negative 2 and negative 6. Split it up, and I get 12x squared minus 2x minus 6x plus 1. The first two I'm going to factor out 2x and be left with 6x minus 1. In the second set, they don't have a common factor, but you can see that here x is negative, but inside the brackets x is positive. Well, the only way I can flip the signs is I'm going to divide out a negative 1. It's going to flip both the signs here, and I'm going to wind up with positive 6x and negative 1, and now they match. So it's going to be 2x minus 1 and 6x minus 1. If it's in a different order, it's fine as long as it is either descending by degree or ascending by degree. And I can still do the same process. 15 and negative 2 gives me negative 30. Two factors of negative 30 that add up to negative 7 are positive 3 and negative 10. So I have 15 plus 3y minus 10y minus 2y squareds. Factor out the first two, and I can pull out a 3, and I'm left with 5 plus y. Factor out of the second two, and I can pull out a negative 2y, and I'm left with 5 plus y. Because what's in here is the same, I can say that it's going to be 3 minus 2y and 5 plus y. For example B, I could take the 15 times the negative 10 and get two factors of negative 150, but like with everything we've done, the first step I'm always looking for, if it's possible, is there a common factor? And there is. I can divide all these terms by 5. So I'm going to pull out a 5 first, and I'm left with 3k squared plus 1k minus 2. One of the biggest benefits here is I'm dealing with much smaller numbers. Is it possible to find two factors of negative 150 that add up to 5? Yes. Is it easier to find two factors of, well, 3 times negative 2, negative 6 that add up to positive 1? Absolutely it is. The smaller the numbers, the easier it is to solve. In this case, it's just going to be positive 3 and negative 2. So I still need to remember that there's going to be that common factor of 5 on the outside, but I'm going to do all the rest of it the same. 3k squared plus k minus 2k minus 2. Still factor by grouping. And I have k and 3k, I'm going to pull out 3k, and I'm left with k plus 1, and negative 2, and I'm left with k plus 1. So it's going to be 5, what's inside the brackets, k plus 1, and what's outside the brackets here, 3k minus 2. Like what we saw with our inspection, when we add a second variable, it doesn't really change our factoring process at all. The biggest thing we need to remember is that at the end, instead of being x plus a constant and x plus a constant, to get the y squared, it's going to be x plus something y and x plus something y. That's the same reason why we have the xy in the middle. Everything else stays the same. So I multiply the first term and the last term, and I get 4. Two factors of 4 that add up to negative 5 are negative 1 and negative 4. I'm going to split up my middle term, and I'm going to get 2x squared minus 1xy minus 4xy's plus 2y squareds. And then when I'm pulling out the common factors, when I factor by grouping, the first one has an x in both of them, and the second one, I'm going to pull out negative 2, and they both have a y, so I'm going to pull out a y from each of them, and be left with 2x minus y. What's in here matches, so it's going to be 2x minus y and x minus 2y. Same thing with example B. I'm going to take the 2 times negative 15, get negative 30. Two factors of negative 30 that add up to negative 7 are 3 and negative 10. And when I split it up, I'm going to have 2n squared plus 3nm minus 10nm minus 15m squared. When I factor by grouping, the first one I can only divide out an n, and I get 2n plus 3m. In the second one, I can pull out the negative from both of them. They're both divisible by 5, and they're both divisible by m. And I'm left with 2n plus 3m. What's in here is the same, so it's going to be 2n plus 3m and n minus 5m. And I'm good to go. All right, go get some practice.